Well, so today what we are going to discuss is the Bode plot. If the Bode plot is given, okay, so then how do we obtain the transfer function of the system? So derivation of transfer function, we can say this as derivation of transfer function from Bode plot. Now when I say Bode plot, we can derive the transfer function from the magnitude plot of Bode plot. So if I have Bode magnitude plot given, I can obtain the transfer function of that system. This is one benefit, one advantage of this Bode plot which we do not get in any other method. Okay, so suppose we have the Bode plot given, magnitude plot is given. How do I obtain the transfer function? So to obtain that, what are the steps that we follow? First thing that we need to know is the starting slope. What is the slope in the beginning? So this one, when Bode magnitude plot is given, of course the approximate plot that is, so I have to check what is the starting slope. If the starting slope given is 0 dB per decade, then I can say there are no pole or no zero at origin. So only thing that decides the starting slope will be present if there are any pole or zero at origin. Okay, either S term in the numerator or S term in the denominator will decide this starting slope. So if there are no S term in the numerator or denominator, that means the slope will be 0 dB per decade. If I have starting slope as say minus 20 dB per decade, that means I have one pole at origin. If I have minus 40 dB per decade as the starting slope, then I will have two pole at origin. If I have plus 20 dB per decade slope, that indicates I will have one zero at origin. What does this means? This means in the transfer function, this term means in the transfer function, I will have 1 by s term. This means in the transfer function, I will have 1 by s square term. This means I will have s term. If it is plus 40 dB, then it will be s square, plus 60 dB, s cube, and so on. Okay, so first thing that we need to check is the starting slope. If I know the starting slope, I'll be able to get how many poles or zeros are there at origin. This is the first point. The second point is I have to find out the value of k, right? How the transfer function can be written. Transfer function can be written as k multiplied by, say, it will be 1 plus st1 into 1 plus st2 and so on, divided by s to the power n. How many s? Either here or here, whatever it is. 1 plus s into ta into 1 plus s into tb and so on. Like this will be the transfer function, right? So from the starting slope, I'll be able to get this first term. How many poles are there at origin, or how many zeros are there at origin. From the second step, I should be able to get this value of k, the constant term. How do I get this? At any frequency, if I know the magnitude, then I can find out the magnitude at that point, at that frequency. So at frequency omega 1, I can calculate the magnitude as 20 log k minus n times 20 log omega 1, where n is this, n is this n. This n and this n are same. So if I have it as a pole at origin, so in the denominator I have say s, then this will be 20 log k minus n is equal to 1 then. If I have 1 by s, then n is equal to 1. If I have s square, it's not 1 by s square, it is s square. then this n will be minus 2. So this will be plus 2 in that case. So this is a minus sign if I have pole at origin. This will be plus sign if I have 0 at origin. So 20 log k minus n 20 log omega 1. This is the same thing how we have calculated the starting magnitude. So for starting magnitude, we have calculated magnitude is equal to 20 log k minus 20 log starting frequency if I have one pole at origin. If I have two poles at origin, then this n will be 2 multiplied by that. And here I will have a plus sign. This sign will be plus if it is a 0 at origin. So plus sign is for 0 at origin, and minus sign is the sign minus for pole at origin. Okay, so from here I'll be able to get the magnitude at omega 1, at any frequency omega 1. By writing this equation, I'll be able to calculate what is the magnitude. This is one thing. Second thing is, from the given Bode plot, I will at least know at any particular frequency what is the magnitude. One value I will know. So I will substitute this for that particular frequency and then equate, and then finally find out what is the value of k. So from this second step, I'll be able to get what is k. Right? Now going to the third thing. What is the third step? Third step is identify the change in slope. So where are the changes that is occurring? Where are the changes that is occurring? I have to identify those points. How much is the change? If I know the change in slope, then I'll be able to identify that factor. So let me explain this clearly. If I have a change in slope, right? Slope was say 0 dB. Now I have a slope like this, which is minus say 20 dB per decade. Where the change is, at this point the change is. What is the frequency here? So this is the corner frequency. This I call it as corner frequency. Now, here the slope was 0. Now the slope is minus 20. So how much is the change in slope? From 0 it is going to minus 20. So change is minus 20. Right? So from the change, I will be able to identify what kind of factor is there. So if I have, now let me write here, if the change in slope is minus 20 dB per decade, then what is the factor that I will have? Minus 20 dB per decade means I will have the factor as simple pole. If I have corner frequency as say omega C1, some corner frequency I am getting, then the factor will be simple pole, right? So 1 by 1 plus S divided by omega C1. This will be the factor. If I know the corner frequency and I know what is the change in slope, then I can obtain the factor. So if it is omega C1 is the corner frequency, change in slope is minus 20 dB per decade, then the factor will be 1 divided by 1 plus S by omega C1. At corner frequency omega C2, say I get a change which is plus 20 dB per decade, then the factor will be, this is plus, so it will be simple 0. And the factor I can write as 1 plus S divided by omega C2. Okay, if I have at omega C3 plus 40 dB per decade, two things are possible. One, which is a 0, plus means 0, minus means pole, that's simple. If it is 20, then it is single pole or single 0. If it is 40, then double pole or double 0. Now when I say double, it is possible that it will be a complex conjugate, or it is possible it is like two poles at the same place. Okay, you can either have two poles like that, or you can have two poles here itself, double pole. Okay, now without any additional information, I will not be able to find out the complex pole. So what I will do, if I get plus 40 dB per decade, I will take it as the factor I'll call it as double zero, and then I'll write it as 1 plus s by omega c3 square. This is easier one. Like, of course, not perfect one, not the correct exact one, but yes, this is easier one. Whenever I have plus 40 dB per decade, if there is no other information given, then I will take it as 1 plus s by omega c3 whole square. Okay. If I have here minus, then it will be 1 divided by. That's all. Right? So this is how we can obtain, if I know the changes. At this point, I have a change from 0 to minus 20. So at this point, I will have a simple pole. How do I calculate that factor? I calculate it this way. If I have here, now this is minus 20, now it is again 0. So what is the change? Here it is 0, it was minus 20. So the change in slope is plus 20. So what do I get? Plus 20 means simple 0. So 1 plus s by omega c2 if this frequency is omega c2. So that is how I calculate. Okay. Now once I get all these factors, how do I write the transfer function? It will be k. Then if you get pole at origin, you will write here s. If it is double pole at origin, then it will be a square. Okay. If it is zeros at origin, then that s will come here. Remember, either this term will be present or this term will be present. Both cannot be present together. Then just multiply these factors. So what are these factors? This is simple pole. 1 divided by this. So I will write that 1 plus s by omega c1 in the denominator. Here this is multiplied by. So I'll write it here 1 plus s by omega c2. Here this is also double 0. So I will write it in the numerator 1 plus s divided by omega c3 square. So like that. So this will be the transfer function. Okay, let's take an example. Then it will be more clear. So let's take one example. Say, just like that, I'll draw something. Say this Bode plot is given. Okay, so it's coming like this at up to certain frequency. Here, say this slope is given minus 40 dB per decade. Then the slope changes to minus 20 dB per decade. Then again the slope changes to minus 40 dB per decade. Okay, so suppose this is given in the problem, and then what else is given? It's given that at certain frequency, say here the frequency is say 10, at 10 this magnitude is given say 20 dB. Say this frequency here it is given as say 40 dB. 40 radian per second. Here this frequency is given as say 1000. In x-axis you have omega, which is in radian per second. Right? This much information is enough to obtain the transfer function of the system. So it has a slope of minus 40 dB per decade from the beginning, and the first change happens here, which is minus 40 radian per second. At that frequency, change happens. Minus 40 dB per decade slope to minus 20 dB per decade slope we have. Then at 1000 radian per second, from minus 20, again I get minus 40. So for this problem, how do I solve it? First step is, what is the starting slope? The starting of the graph itself has minus 40 dB per decade slope. So I have starting slope is minus 40 dB per decade. What does this mean? This is negative sign. Slope is negative. So there is pole at origin. Minus 40 divided by 20 I have to do basically. It is always a multiple of 20 only. It cannot be anything else. You cannot have starting slope as minus 30. That's not possible. Okay. Starting slope is minus 40 dB per decade. This indicates I have two poles at origin. That means, what is the factor that I get? Two poles at origin. So 1 by s square is the factor. So this is the factor. corresponding to this term, because the starting slope is this, so I get a factor 1 by s square. If this was plus 40, I would get s square. If this was minus 20, I would have got 1 by s. If it is plus 20, I would get s, like that. And if it is 0, if there is no starting slope, then there won't be any pole or 0 at origin. So this is the first step. What's the next step? Next step is what I have to check is what is the value of k. Now, to obtain that k, which magnitude do I know? I know at 10, at frequency 10, I have the magnitude as 20. So I can write at omega equal to 10, magnitude is 20 dB. How do I calculate magnitude at omega equal to 10? I calculate it as 20 log 10, then minus of how many poles are there at origin? 2 poles are there at origin. Because it is pole, so it is minus sign. How many? 2. So 2 multiplied by 20 log, at which frequency do you know the value? At omega equal to 10. So 20 log 10. So this is the magnitude, sorry, one second, one mistake I have done, it is not 10, this is my 20 log k. I am trying to calculate the value of k, so it is 20 log k, this is minus sign because it is pole. If it was 0, then it would have been plus sign. How many poles are there at origin? 2, that is why 2 here, 2 multiplied by, this 2 comes because of this 2, 2 multiplied by 20 log, what is this frequency? 10, that is why 10 here. Okay, so 20 log k plus or minus, plus if it is 0, minus if it is pole. Here the number of poles or zeros, number is 2, so here 2 here, 2, multiplied by this 20 log remains as is, and this 10 becomes, 10 comes from, because you know the magnitude at omega equal to 10, so you are writing it as 10, and that's equal to given, which is 20. Now from here you should calculate k. So how do I calculate? 20 log k minus 2 into 20 log 10. 20 log 10 is 1. So it will be minus 40, which is equal to 20. So I get 20 log k equal to 60, which gives me log k equal to 60 by 20, that is 3. So k is equal to 10 to the power 3. Okay. So from here I'll be able to get the value of k. Now once this is done, then the third thing that we have to do is we have to find out the other factors. Now how do I get the other factors? I have to identify the points where the slope has changed. Where all the slope has changed? Slope has changed at this point. This is one point where slope has changed. Okay, this is one point where slope has changed at 40 frequency. From minus 40, the slope has gone to minus 20. So how much is the change? What I get now is minus 20 minus of the previous slope. Current slope minus of the previous slope. So from minus 40 it has gone to minus 20. So the change is plus 20. Here from minus 20 to minus 40. So the change is minus 20. Okay. What are the frequency? At this point frequency is 40. At this point the frequency is 1000. So only 2 times the change has happened. So after this, what we are going to do is we'll write a table. In the table, I'll write what is the corner frequency, means at which frequency the change has happened. Then what is the change in slope that I will find out. What is the change in slope that I will calculate. Then I will write what is the factor. So first, what are the corner frequency? Corner frequency is at 40 and at 1000. At these two frequencies, slope has changed. So, at 40, what is the change? How do I calculate change? Final slope minus previous slope. So, slope can be calculated as minus 20 minus of minus 40. Currently, it is minus 20. Earlier, it was minus 40. So, minus 20 minus of minus 40, which is equal to plus 20 dB per decade. And for 1000, from minus 20 it has gone to minus 40. So the change is minus 40 minus of minus 20, which is equal to minus 20 dB per decade. So this is the slope. Now if the slope is negative, then I will have a pole. If the slope is positive, I will have a 0. It is a simple pole because it is plus 20 and minus 20. So only one term. So how do I write the factor? Because it is positive sign, for the first one, it is positive sign. So the factor would be in the numerator. So how it is? 1 plus S divided by the corner frequency. So which is 40. So this will be the term because of the first one. For the second one, it is negative slope. Change is negative. So 1 divided by 1 plus S divided by corner frequency 1000. So how many terms are there total? 4 terms. 1 is the constant term where k is equal to 10 to the power 3, this term. Second one is 1 by s square, this term. So one term here, and I have one term here and one term here. Just multiply all these terms to write the final transfer function. So how do I get the transfer function? Transfer function is equal to k, which was 10 to the power 3, multiplied by, here it is 1 by s square, then it is 1 plus s by 40 divided by, this is in the denominator, so 1 plus s by 1000. That's it. So this is the final answer of the transfer function. Okay, so taking the graph, I'll just repeat it once, the steps. Taking the graph, first thing that we need to do is identify what is the starting slope. Starting slope is minus 40 dB per decade. This is negative. This negative sign indicates it is pole. It is 40 multiple of 2 times of 20. That is why 2 poles at origin. If this was plus, I would have got here 2 zeros at origin and the factor would have been s square. If this was plus, it would have been, in place of poles, it would have been zeros, and in place of 1 by s square, it would have been s square. So these are the changes, right? So if it is minus 20, then I would get only one term. So only one pole, so it would have been 1 by s, and so on. Second thing is, at which frequency do you know the magnitude? At 10, you know the magnitude. So at omega equal to 10, magnitude is 20 dB, which is known to us. So now what I will do, 20 log k, this minus sign, because it is poles here, it would have been plus if it was 0. Here it is 2. This 2 comes from this 2. The power of s is 2 because I have 2 poles. So here it will be 2. 20 log. Here this is 10 because at 10, omega equal to 10, you know the magnitude. So this is 10. So 20 log k minus 2 into 20 log 10 is equal to 20. From this equation, now calculate what is the value of k. Once this is done, then we'll go to the next step where I have to identify where all slope has changes. Slope has changed. What slope has changed? It was minus 40 dB per decade from here to here. Then at this point, at omega equal to 40, the slope changes to minus 20. So omega equal to 40 is one corner frequency. Then omega equal to 1000 is another corner frequency, because even there I have a change from minus 20 to minus 40. I have a change. So these two are the corner frequencies. Go to those corner frequencies and identify the factors. How do I identify the factor? So for that, at corner frequency omega equal to 40, what is the change in slope? Earlier the slope was minus 40. Now the slope is minus 20. So the change is current slope, that is minus 20, minus of the previous slope, that is minus 40. That gives me plus 20. This plus sign indicates I have a pole, this plus sign indicates I have a 0. Because it is 20 dB per decade slope, so it is simple 0. The second factor tells that I have minus 40 minus of minus 20, so negative 20 dB per decade. So this is minus, so I will have a pole here. This is 20 dB per decade, so I will have a simple pole here. Okay. How do I write the factor? Because it is 0, so it will be in the numerator. If it is pole, it will be in the denominator. So 1 plus S divided by this corner frequency. The term is actually 1 plus ST, which is nothing but 1 plus S by omega. This is the term. Okay. So 1 plus S by 40. This is one term. Here the term is 1 by 1 plus S by 1000. Right? Finally, what I have to do, all the terms I have to write it together. Just multiply the terms to get the transfer function. So this will be the final transfer function. Okay. Is that fine? So let's take one more problem. Let's take this problem. I have the slope, say minus 40, then the slope changes to 20, then the slope changes to 0, then again it changes to like this. Say this frequency is, at this point frequency is 1, at this point frequency is 10, at this point frequency is say 100, here frequency is say 400, something like this. Here the slope is given plus 40 dB per decade. Here slope is given plus 20 dB per decade. Here it is a straight line like horizontal line, so it is 0 dB per decade. 0 dB per decade. Here it is minus 20 dB per decade. And say here it is minus 60 dB per decade. Okay. And say I know the magnitude at this point, and the magnitude is say 40 dB. One important point for the second step that we have solved. For the second step that we have solved in the previous problem, this part, this K calculation, remember that when I am calculating this K, I am writing this equation, it should be, the magnitude that I know should be with the starting slope itself. If I know the magnitude here, I cannot use it directly like this, how we have done. So magnitude should be known for the first part of the graph, that is with starting slope itself. If you know this magnitude, from here somehow you should be able to calculate the magnitude here, and then you have to continue. Okay, so you cannot write this equation for the slope which is not the starting slope. Okay, it has to be the starting slope only. Keep that in mind. Right? Now, we will not consider that at this moment, that if the slope is like here the magnitude is known. I will just consider that we know the magnitude in the starting part only. I will tell you the remaining thing later. So at this point, I know the magnitude here, which is 40 dB at 1, and it is with the starting slope itself, so no problem for me. I have to obtain the transfer function for this system. So how do I get it? So first step is starting slope. What is starting slope? Starting slope is given, which is 40 dB per decade. So if it is 40 dB per decade, what will be the factor? Can you tell me what will be the factor? Plus, so it is pole, right? 40, so I will get S square will be the factor for the first part. Plus 40 means 2 poles. So S square is the factor. This is the first step. What's the next step? Next step is Magnitude is known at omega equal to 1. 40 dB is the magnitude. So how do I calculate? 20 log K. This is pole. So it is plus. Previously it was 0. So I had put here minus sign. Now it should be plus. Plus 20 log 1. This should be equal to 40. 20 into 2, sorry. Here 1, 2 into 20 log 1. Log 1 is 0. So this second part will be 0. So what do I get? Log K is equal to 40 by 20, which is equal to 2. So K is equal to 10 square. Okay. K is equal to 10 square. So this is what I'll be getting it as the second term. K is equal to 10 square, right? So next what I will be doing, once I know this case K, what's the next step? Next step is identify the factors. So what are the factors that I have? What are the change? Where are the changes that I am getting? I am getting one change which is here. What is the corresponding corner frequency that I have to find out, right? Corner frequency, then change in slope I have to find out, and then I have to find out the factor. So first at this point, what is the corner frequency? It is 1. Here there is one more point here where I have a change. So what's the change here? What is the corner frequency here? 10. Here also I have a change. Corner frequency is 100. Here also I have a change. Corner frequency is 400. So at one corner frequency, how much is the change? From plus 40 to plus 20. So it is a reduction of minus 20 dB per decade. So change in slope is minus 20 dB per decade. At 10, plus 20 to 0. So again, I have minus 20 dB per decade as the change in slope. Plus 0 to minus 20 at this instant, at this corner frequency. It was 0, now it is minus 20. So the change is again minus 20 dB per decade. What is the change in the next part? Here, from minus 20 to minus 60. So the change is minus 40 dB per decade. Okay. So every time I have minus 20 change, here the last part, the change is minus 40 dB per decade. Now I have to identify the factor. So all are poles because all are negative change in slope. So first factor will be 1 divided by 1 plus s by 1. So 1 by 1 plus s. For the second one, it is 1 by 1 plus s by 10. Third one, it is 1 by 1 plus s by 100. S by 100. But the fourth one, change is minus 40. So I can write it as 1 by 1 plus s by 400 square. That's it. Okay. Now I have total of 4 terms, 6 terms. Here I have, this is one term, s square, this is k, then this is 1, third, fourth, fifth, sixth. All these terms you can multiply and write the final transfer function. Okay. How do I write that? I can just write all these terms combined and then write the transfer function. Let me write the transfer function now. What it will be? K multiplied by s square. K is also known. K we have calculated 10 to the power 3 multiplied by s square divided by all the remaining term. This 10 to the power 2, sorry, not 10 to the power 3. 10 to the power 2 into s square is in the numerator. In the denominator, 1 plus s by 10. 10 to the power 2, not 3. S square. Here it is 1 plus s. This is the first term. 1 plus s by 10. Okay. Then third term is 1 by 1 plus s by 100, then 1 plus s by 400. So here 1 plus s by 100, then 1 plus s by 400 squared. Okay, is that fine? Now if I have the start frequency which you know, at which frequency at which you know the magnitude, say it is something like this. You do not know the magnitude here, you know the magnitude here. Here the slope is plus 40 dB per decade. Here the slope is plus 20 dB per decade. Say, okay, you do not know this magnitude, but you know this magnitude is 40. So to calculate, if you know this, then you have to calculate the magnitude here first. Suppose here the frequency is 1 and here the frequency is 10. Okay, so what you have to do, if this is 40 dB, if the slope here is plus 20 dB per decade, then what would be the magnitude here that you have to calculate? See, the slope says slope is 20 dB per decade. So from 10 to 1, there should be a change of 20 dB. So here if it is 40, then here it must be 20. Okay, if this is 40 here, at 1 it must be 20. So like that you have to calculate. This is just a linear graph, it's a straight line. So you have to use the relationship y equal to mx plus c to calculate what would be the magnitude here. So here it is quite simple, this is 1 and this is 10. So if at 10 the magnitude is 40 and the line has 20 dB per decade slope, then what would be the magnitude here? Naturally, in 1 decade, the reduction should be 20. So I can say, or here it is increase should be 20. So here if it is 40, then here it must be 20. So from that you will get 20, and after that you will write it as 20 log k plus, at this point the magnitude is 20. So here what is the frequency? 1. So this is 0. So plus only one pole. Here what is that? 40 dB per decade. So 2 poles. So 2 multiplied by 20 log 1. So this will be equal to 20. Like that you have to write. You cannot write it as here 10 and here 40. That's not correct. That will give you wrong answer. Okay. So when you are using this first equation, 20 log k plus or minus n times 20 log omega 1, there this magnitude substitution should always be with the starting slope and not with any other slope. Okay, so from here we'll be able to get this k value, right? So that's about your calculation of transfer function, derivation of transfer function when you know the Bode magnitude plot. Okay.